Hello everyone, my name is Debashish Roy. I am the Senior Network Analyst at the Indian Cyber City Solutions, and I welcome you all to this special live session today. And today's topic is static routing versus dynamic routing, use cases and labs. So we'll discuss and compare between the routing types like the static routing and dynamic routing. These are the two routing types you have mainly. And also we'll see the practical configuration, what is the use case, where do you configure, how to configure it, and the labs will perform. So let's begin. So discuss the static routing versus dynamic routing, and we will discuss in depth the comparison of static and dynamic routing methods, and also the practical approaches, how to configure it, and the lab exercises. So what is the routing? Routing is actually sending the packet from one location to the other, from one network to the other network, and say from class A network to class B to class C to different classes of networks. If you are sending the data, that is the routing, and it is of two types, static and dynamic. So, what are those? So, you have to understand the importance of the routing in networking first. Routing is very essential for, say, directing the data packets, means sending the data packet between networks that I was telling you, and ensuring that information reaches its intended destination. Means there is a network, say here in source A, and you are having a network at source B. So you are going to send the data packet wisely there so that it reaches, and definitely it reaches the destination. It is a reliable connection. It enables seamless communication and connectivity in complex network environments. So you have to understand the static routing first. So what do you mean by the static routing? Now, static routing involves, say, manually setting up paths for data packets within a network. What does it mean? It means that you have to manually configure the entire path from the source to the destination. That is the static routing. Everything you have to do it manually or statically. So, if there are too many destinations, yes, it is a problematic or challenging thing for you. And this method ensures that routes remain constant until a network administrator changes them. So if some change happens, if the source network or the destination network changes, then what will this network administrator do? He has to change it manually, making it a stable choice for predictable network environments. So if you're having a small network, say a small PC, say 10, 12 PCs there, then you are having 10, 12 destinations, then you can go for this. But if there are too many destination networks, say all over the world, it is definitely a challenging process for you. Then what are the advantages of static routing you have? Its simplicity in configuration, so it is very straightforward approach to configure and implement the static routing, and requires a minimum configuration effort, and which actually helps you to quick deployment and management of routing tables of the routers. Then it has lower overhead on routers, means lower CPU utilization. Means the static routing here, the route is entirely configured, so the routers don't need to process much, because the entire route from the source to destination, it is already there. So the router has to send the packet through that route. So in case of the dynamic routing, it has to process, but in case of static routing, no. Static routes consume fewer resources, fewer CPU cycles on the routers, and as they do not require continuous updates or processing of dynamic route information. Like in case of dynamic routing, say OSPF or BGP, you have the automatic updates. So whenever some, say, some interface is added, some network is added, automatically that update is sent, and that is also having some CPU utilization. And that is why the static routing leads to better overall performance. Now, enhanced security, that is also an advantage, as static routes are not shared over the network. They provide better security against unauthorized access and different routing attacks also, so it is safe to configure the static routing. Now, what are the disadvantages of static routing? Let's understand. It is lack of scalability, because it does not scale well with large networks. So if you're having large networks, say if you're having hundreds of networks, then definitely the scalability is not there, because you have to change the route again and again. As the number of routes increase, that I was telling you, managing and configuring them manually becomes more complex and time consuming, because you have to change the network address every now and then. Again, increased administrative burden is there. Means with static routing, network administrator must manually update the routing table or routes when any change occurs. Now, that is not an efficient process at all, because this can lead to increased workload, increased pressure, and the potential for the human error in network configuration is there. So, if you are doing it manually, if you are updating manually, definitely the error prone that should be. Inability to adapt means static routing does not automatically respond to changes or any update in the network. If, say, for example, I add any interface, will it come to the static route? No, because I have to manually configure the static route. I have to manually add that network to the routing table. That is the biggest challenge. And if a link fails or a network topology changes, the routes must be manually reconfigured, and it leads to potential downtime, and say the connectivity issues are there. Now, understanding the dynamic routing. So that was the static routing. And what is the advantage of dynamic routing? Does it solve the static routing problems? Dynamic routing is a network routing method which uses the automatic path selection based on certain conditions, and they include the routing protocols. And this approach utilizes various routing protocols to identify the most efficient route, that is the best path selection for data transmission, and it ensures optimal performance reliability. So, what are the advantages of dynamic routing? First is the automatic route updates. So, the dynamic routing protocol automatically update the routes, as I have told you, that if some changes happen, you do not need to manually do anything. Say, let's say the OSPF protocol, it has a LSA, link set advertisement, or the BGP protocol, the routing prefixes it has. So, the NLRI that we say, so it is automatically sent to the other routers, and it ensures that the most efficient paths are utilized without the manual intervention, and it leads to enhanced network performance and reliability. So the dynamic routing protocol is automatic, and its automatic approach, it is more reliable than the traditional static routing. Then the scalability, the dynamic routing is very scalable because OSPF designed like it is having the autonomous system, the areas. This ensures scalability, and it can handle larger networks. Like you say about the BGP protocol, it actually have almost like 40 million prefixes, even more. So it can scale effectively as the network grows, and it accommodates additional routers and links without the need for extensive manual configuration. So there is no need for any extensive manual configuration. You just add the source networks, and the destination it will process. Adaptability to changes, that is also an advantage. Like in dynamic routing protocols, it can automatically reroute traffic in response to network failure. So if you are having multiple links, redundant paths, you should have not only one path. So one path goes down, the traffic is rerouted or shifted to the other path. Like you are having an HSRP protocol there, GLB protocol there, like that. You are having the protocols in the routing also, like the OSPF or BGP. It also actually does the load balancing. This adaptability is crucial for maintaining service levels in critical environments. So this is very, very important here. Now, disadvantages of dynamic routing we'll discuss. First is the increased resource consumption, definitely, because it requires more resource and processing power, because you haven't told the router which path it should take to reach the destination. It has to find out. So definitely increase CPU consumption, which can lead to increased overhead on routers, CPU, and potentially slower performance. Definitely, that is the issue because dynamic routing is slow compared to the static. Potential security vulnerabilities are there because dynamic routing can expose network information through routing advertisements, making networks more vulnerable to attacks such as route spoofing or the spoofing of the MAC address spoofing. If you are say changing the MAC address of one device, you are spoofing the MAC address, that MAC spoofing attack can say, which could compromise network security. It can happen. Then troubleshooting is complex here. The complexity of dynamic routing can make troubleshooting more difficult for network administrators. Now, this part I think it is a bit more difficult, you can say, than the static routing. So, as they must understand various protocols, so that knowledge and expertise should be there, and the interactions. So, that is there in the dynamic routing, leading to longer resolution times of your issues. So ideal scenario for static routing, it is in a small network where the overhead is lower. You can say that there we use the static routing because it is faster. And limitations, definitely I have told you that in complex networks where is the big network you are having and it fails short in flexibility and adaptability, static routing can become cumbersome as it requires manual update. So definitely the static routing is not ideal for you if you are having too many destinations, say too many networks worldwide. Say you are managing an MNC or you are managing a cloud data center ISP, definitely they do not go for static routing, they will go for the dynamic one. But if you are having a limited resource, limited company, limited branches, then you can go for static routing easily. The large and complex networks we're having, dynamic routing is ideal for large, more complex networks where adaptivity is crucial. And because it automatically adjusts routes based on current network conditions, it can send automatic updates that I have discussed. And load balancing and redundancy is there that also I discussed, like the HSRP, the GLB protocol. They require the load balancing and redundancy. Means you are not only having one path, but you are having the multiple links, and automatically the traffic is shifted to other links if some failure is occurred. Now it is essential for multi-access networks where say the multiple devices share the same connection. So non-broadcast multiple access that I'm talking about, or the broadcast network, allowing for efficient data distribution and reliability. So now we will actually do the demonstration, that is we will do the configuration of the step-by-step configuration of the static routing and the dynamic routing. So now let's move to the other simulator, that is the Cisco packet tracer that I have. And for the lab, I will show you first the static routing configuration between the two routers, and then we will configure the dynamic routing. One thing we must remember, that static and dynamic at one point of time cannot be configured at once, because if you configure static routing, then the AD value is 1, and let's say you configure the OSPF, the dynamic routing protocol, we know that the AD value is OSPF is 110 or EIGRP is 90, that is the internal EIGRP I'm talking about. So definitely the static routing has lot less AD value, that is one. So definitely the router will not show up the, say, the dynamic routing in the routing table, so you have to remove the static route then. So let me take two routers now. You connect it with say the serial cable, and you can connect the PCs as well with the fast Ethernet port. Go to the CLI, bring up the interface. IP address is say 10.0.0.1. Give the mask. It should have the default mask in case of the static routing. That is also another point. And serial interface, you have to give clock rate because it is a DCE that you have connected, and give the IP address say 11.0.0.1. This is one part, and the other router, you just go to this, say router 1. In the fast Ethernet, you give the IP say 20.0.0.1 in the 20 network, and in the serial give no shut and give the IP as 11.0.0.2 in the same network, because serial should be in the same network. Now you configure the static route, exit and go back to the config mode, and then IP space root and the destination network 20.0.0.0 and the subnet mask of the destination we have to give, and also the next hop, that is 11.0.0.2, that is the serial port IP of the router 1. And also in the router 1 you give the opposite, IP space root 10.0.0.0 as a destination network, and it is 11.0.0.1. And to view the static route, show IP root static. You can see the static route, that is 10.0, that is pointed to you. And also here also you can see the show IP route and static. So this is a static route that you can see that the AD value is 1 and the cost is 0 because it doesn't have any cost associated to it. The OSPF may have the cost associated but not the static route. So now that is a static route that is done, and it is very efficient because you can see that the entire path here I've defined the destination network subnet mask as well as the next hop. Now you have to remove the static route now and you have to configure the dynamic routing. So what you need to do, you need to just copy this, paste it, and just give no before this. And you configure say router OSPF, say process ID 1, and you configure the networks like you can have here in this case 10.0.0.0 and the wildcard 0.255.255.255 and area 0. Let's say we are in area 0 itself, and network serial that is 111.0.0.0 and the wildcard same, and the area should be 0 again. And on the router one, do the same thing. You go to config and just copy this static route and remove it once. And then you configure the OSPF router OSPF, and process ID can be same, means 1, or it can be 2. I'm giving it 2, say for example, and network say it is 20.0.0.0, the LAN, wildcard mask and area 0, and the network say 11.0.0.0.255.255.255 area 0. You can see the OSPF show IP route, and the OSPF is already started. Let me again. So it should come now because, but it is, I think there is a catch that the PC is not having any IP address, so that is why the route is not being shown. If you see show IP route, now it has come. So now you can see the route in the packet tracer actually checks whether the PC is connected and it has an IP address, and then it is shown. You can see the OSPF route now here, that is 20.0. So the AD value is 110 and the cost is 65. It is connected to the next hub 11.0.0.2, and also on router 1 you can see that now it has come that the 10.0 network, it is connected via 11.0.0.1. So this is actually the configuration of the routes, and you can also like go back to the PCs that I was telling you, and you can go to desktop IP configuration and you can give the IP address like this 10.0.0.2, and it is having the default sign mask here, and the default gateway would be 10.0.0.1 in this case. And here you can see the first Ethernet IP is the 20.0.0.1. So in this PC you have to go to the desktop IP configuration, and again you give the IP in the 20.0.0 network, and the default gateway would be 20.0.0.1. So then you can check the pinging to the 10.0.0.2. So the first one will fail for the ARP, and then it should ping. Yes. So you can see that the reply is coming, and then again if you ping, you will get the 4 replies that is valid in the Windows PC. And also in case of the dynamic routing protocol, you can check by show IP OSPF neighbor. Neighbor is in full state, so you can check the neighbor state here. You can even see show IP protocols which is running. You can see that OSPF the process ID 1 is running and is actually doing the equal cost multipath load balancing ECMP. There is 4 maximum path, it is load balancing, and is routing for the networks of this 10 and 11. You can see the gateway and the AD value, everything you can get. So this is how you configure the static routing, that is the more traditional one, and then you change the static routing, you remove the static routing and actually go for the advanced form of static routing, that is actually the dynamic routing protocol. So I think that is the difference between the static routing and dynamic routing you have. And static routing, although it is a primitive routing, it is a traditional routing, but still it is used because it is faster than the dynamic routing protocol. And if you're having few say branches in your own enterprise, so definitely you should go for the static routing, not for the dynamic routing, because dynamic routing, it is a scalable one. And if you're going to have more networks, then definitely you should have the dynamic routing approach. But other than that, it is faster, so you should go for the static routing. And dynamic routing involves a lot of protocols. I've told you, like BGP, Border Gateway Protocol, that is definitely not available in static routing, or ISIS, say the intermediate system to intermediate system protocol. That is a very advanced protocol in the ISP and say the cloud, say data center levels. But in enterprise networks, you use the OSPF or the EIGRP protocol till date. So that is actually a comparative analysis for the static routing and dynamic routing. And you cannot say which is better or which is worse, because both are essential for the routing and both are two pillars of the routing we have till now. And this is very essential to study and master these two routings in case of the say the CCNA and the CCNP certifications as well. So that is all I have for now today for you about the static routing versus dynamic routing. And I've told you the theoretically, and also I've shown you the labs and the use cases, but use it, and I think you'll be able to configure it and also troubleshoot these routing protocols and routing approaches. And also it will be very helpful for your certification purpose if you want to achieve the CCNA or CCNP or any other certification in your goal. So I thank you all for watching and joining this webinar and live show once again. I will come with some new topic next time. Till then, bye.